Good evening again. This is the lighter side of astronomy, a relatively short talk with essentially no science, no maths, despite what it looks like on the board in the background there, and hopefully just a little bit of humour along the way. So I'll be looking at the lighter side of astronomers and telescopes and observatories and a little bit of miscellaneous that I happen to have found that made me chuckle, and I'll be passing that on. So, some astronomers are of course scientists, and when asked, do you think you have what it takes to be a scientist, Patrick Moore might respond,
we just don't know.
Because that's what he normally says whenever anybody asks him anything. And yes, for future reference, that's pretty much what goes on inside my head all the time. Regardless of what I'm thinking about, yeah, there's always a few equations in there knocking around. And yes, astrophysics can be complicated. I've given you some astronomy and some astrophysics talks in the past. I've tried to keep the maths out of it because most people get pretty befuddled, including a lot of astrophysicists, when it comes to actually dealing with the mathematics and the hard science behind astronomy. But we're essentially going to be doing none of that this evening. Every once in a while, I've shown you this diagram, a diagram of how we classify stars in order to make sense of how stars work. For a long time now, people have been using these so-called HR diagrams, Hertzsprung-Russell diagram. Doesn't matter about the name. It's a diagram in which stars are positioned according to their luminosity on the vertical scale and their temperature or their colour on the horizontal scale. And for historical reasons, it's been coolish stars on the right and hot stars on the left. So why am I showing you this? Well, Hertzsprung-Russell diagrams are normally shown for stars, but I came across many years ago the equivalent of a Hertzsprung-Russell diagram, but not for stars, but for astronomers, where somebody had tried plotting out where astronomers sit on this diagram, where luminosity on the vertical scale has been replaced with, well, how famous are these people? If you like, how luminous are these individual astronomers? And fame has been judged. The metric for fame is, if you Google their names, how many hits do you get? From essentially none down at the bottom to millions at the top. And how do we take the horizontal scale? Well, for want of a better metric, the horizontal scale is how prolific are they as scientists. So the vertical scale is famous for any reason whatsoever. And the horizontal scale, again going from right to left rather than the other way round, is how famous are they in the scientific sense? How many peer-reviewed scientific papers have they published? From essentially none on the right-hand side to hundreds or possibly even more way over on the left-hand side. So a few astronomers have been placed in this Hertzsprung-Russell diagram, literally just as a bit of fun. And bear in mind, it is a few years old and I found it very difficult to update it. So I'm showing you essentially the state of astronomers as of quite a few years ago. So let's have a look at a few individuals. There's a person there who is essentially in the top left of the Hertzsprung-Russell diagram of famous astronomers. They are about as famous as you can get in the sense that they have the highest number of Google hits, and they have published hundreds and hundreds and hundreds of scientific papers. I don't know if you know who that person might be, if you don't attempt to read it off the diagram itself. That individual who is famous as a scientist and famous as a personality is Carl Sagan, because he produced TV programs back in the 70s and 80s. That got him a huge amount of fame, but he is, of course, a very well-respected scientist in his own right. Right next door to him is Stephen Hawking, arguably even more famous, but amazingly enough, having published slightly fewer papers. Let me just get rid of that. So there's Stephen Hawking right next door to Carl Sagan. Almost as prolific in terms of papers and marginally more famous in terms of the number of Google hits obtained. If we come further over to the right, there's Brian Cox. So almost as famous, in other words, the Google hits is a huge number, but actually hasn't published as many scientific papers as the great luminaries like Stephen Hawking and Carl Sagan. I'm not sure why, but way over on the right-hand side here is an individual. Quite how she got into this diagram, I don't know, but this is Mylene Klass. She has introduced a few scientific TV programs, and she is famous in her own right, but as far as I know, she hasn't published any scientific papers. So there we have the individuals that are right at the top of the HR diagram of astronomers. There are other names that you will know in there, such as Neil deGrasse Tyson, Chris Lintott, presenter of The Sky at Night, and Jocelyn Bell Burnell, the discoverer of pulsars, for instance. And there's loads of other names that are scattered around there. The person who compiled this particular HR diagram didn't attempt to put in every conceivable astronomer because that would just be too complicated. But when I first saw this, as well as thinking, oh, that's interesting to see where people sit in this, I thought to myself, I wonder, where do I sit in the HR diagram of astronomers? I'm an amateur astronomer, but a professional physicist. So I have published scientific papers. I've published a little over 100 scientific papers in my lifetime. And I figured, well, it's worth Googling to see how many times my name crops up. Googling Stephen Barrett doesn't help. Googling Steve Barrett doesn't help because there are far too many of those in the world. And there's actually quite a few Dr. Steve Barretts in the world. There's at least a couple famous ones in America and others dotted around the country as well as the world. So I had to Google Dr. Steve Barrett in quotes to make sure that was all together. And I added Liverpool to make sure I didn't pick up any Steve Barretts beyond the UK. And I found I had about 5,000 hits. So that meant that on this diagram, that put me there. Just over 100 papers, 5,000 hits. That means I'm a main sequence, totally average sort of scientist. Nowhere near as luminous as the Chris Lintotts and the Brian Coxes and the Stephen Hawkings of the world, but at least I'm somewhere near the middle. So I took some solace in that. Let's have a look at a few cartoons that I've picked up along the way. Here we have a couple of cavemen looking through hollow logs, so telescopes without any lenses and without any mirrors. So of course they don't magnify. And here one caveman is a little bit dejected. You say this is the most powerful one you have. If they're all hollow logs, then of course the moon will look exactly the same through any small hollow log or large hollow log. But what I found particularly amusing about this is the fact that clearly we have a customer thinking of buying one of these telescopes, $8, $2, etc. But I also like the fact that the salesman has got a rather nice coiffured hairdo and is wearing a tie. That's a great way of presenting a caveman salesman. There's an eclipse coming up next month on the 12th of August. A partial eclipse for us in the UK, a total eclipse if you want to travel to Europe. And I thought this was quite amusing. I guess you can't see it too clearly, but that says sundial repair. Because you might be using a sundial before the eclipse, then the sun goes away and the sundial of course doesn't work, and then the sun comes back again. And this individual was then complaining that basically it happened right after the eclipse. It just keeps blinking 12 o'clock. For those of you with a digital alarm clock, you'll know exactly what that's like when the power is lost. Another time device as well as calendar is something like Stonehenge. We're all sort of familiar with the idea that you put stones in the ground and you can see where the sun rises, where the sun sets, and you can use it as a calendar or you can use it as a clock. But these particular individuals, who presumably are either architects or people who came along shortly after Stonehenge was built, they make the comment that when summertime ends, we have to give everything a slight turn to the left. Maybe we will stop moving the clocks forward and moving the clocks back twice a year, but for the time being, it looks like that is going to continue happening. This pair of individuals is looking at these large stone blocks. They might be part of a pyramid, they might be part of something else. But one is saying to the other, it's a complete mystery as to how the ancients managed to move these massive stones. And again, if you were to ask Patrick Moore, the response would be, well, we just don't know. But in this particular case, the hint as to how these large stones got moved is given by the left-hand side. You can take that any way you like. I came across a few cartoons along the way of individuals. I wasn't sure how many astronomers famous enough to be caricatured was worth collecting, but I found a few that are perhaps worthy of note. Galileo, who's famous for the apocryphal experiment of going to the top of the Leaning Tower of Pisa and dropping off cannonballs of different sizes and showing that a large cannonball actually hits the ground at the same time as a small cannonball. Despite the fact that our gut feeling is that large objects ought to fall faster, he was determined to show that, well, it's not a question of gut feeling. If we're going to do science, we should do an experiment and find out what the actual answer is. Of course, even from a great height, it doesn't take long for two cannonballs to hit the ground, and some people have said, well, Galileo back in the 1600s was hampered by the fact that he could only do experiments to a certain precision. And the question was being raised, well, what if there were computers in Galileo's time? Would that have enabled him to do far more accurate experiments? Well, some have said yes, and some have said, well, no, he would have got so frustrated, instead of throwing cannonballs off the top of the Leaning Tower of Pisa, he would have just thrown computers off the top of the Leaning Tower of Pisa. We've all met that sort of level of frustration. What about Isaac Newton? Everybody is aware of the, again, possibly apocryphal story that Newton discovered gravity or started thinking about gravity after an apple fell on his head. I've visited Newton's birthplace, and it's where he spent some years of his life. And indeed, there is an orchard there, and there is an apple tree that's something like 400 years old. So it's possibly the tree under which he sat, and then the apple fell on his head. So that's the standard story. But some people have said, well, maybe Newton discovered more than gravity. Yes, the apple would have made him think about gravity, but some have said, actually, Newton also discovered humour, or comedy, due to the classic anvil on head routine. And for those with a more surrealistic attitude, some people have said, well, actually, Newton discovered surrealism as well. What about Carl Sagan himself? Perhaps some of you remember the series from the 1980s, Cosmos, where he talked rather lavishly about how large the universe is and how many stars there are in the galaxy and how many galaxies there are in the universe. But a Far Side cartoon some years ago, I quite like this one. Just look at all those stars. There must be hundreds of them. Maybe as a kid, that was all he could manage. Perhaps you know... Oops. Perhaps you know that in his later days, he was well known for the way he would pronounce millions and especially billions of stars in the galaxy. Amateurs are very good at interesting ways of making telescopes. These days, we tend to just buy them off the shelf. But of course, for quite a lot of time after Galileo's first use of the telescope to look at the night sky back in the 1600s, people had to make their own telescopes because there were no commercial manufacturers. The Victorians were very imaginative as to how they decided to try and build telescopes. I'm not sure if this one ever existed or whether this was just an idea of somebody. These days, some very talented amateurs can build wonderful telescopes. Here, a very interesting and rather expensive telescope made not out of the cheapest materials available, but made out of metals such as titanium, a very expensive way of doing it. Some amateurs can make telescopes and make amazing instruments. Some really don't have a clue what they're doing. Let's have a think about some of the smallest telescopes that have ever been made. Those of you who are dabbling with astronomy might have heard of fork-mounted telescopes, but generally speaking, a fork-mounted telescope doesn't refer to a small telescope mounted onto a fork which is then glued to a knife and a spoon, but that presumably is the smallest way that you can get a fork-mounted telescope. And what is probably the best telescope in the world? Well, perhaps you can tell from the phrasing, it's obviously a Carlsberg beer can. And yes, this is a real telescope. Somebody took a Carlsberg beer can, they put a small mirror in the bottom, they put an eyepiece in the top, made a hole in the can, and then actually used that as a small telescope. It was probably awful in terms of its optical quality, but it's quite a nice idea based on the Carlsberg adverts that it's probably the best telescope in the world. For some people, one telescope simply isn't enough. And rather than say, well, I can have a small pair of binoculars or I can have a large telescope, some people have decided to build themselves effectively binocular telescopes. So a large pair of telescopes on this common mounting, and by looking into this binocular field of view, one eye is looking through the left-hand telescope and the other eye is looking through the right-hand telescope, which means effectively it is simply a large pair of binoculars. But instead of a binocular with only a few centimetre diameter lens, now we're talking many centimetres diameter mirror in these two telescopes. And that is not necessarily the largest pair of binoculars that's ever been made. That, I think, probably counts as one of the largest. It's, rather than having solid tubes, the telescopes themselves are made with this truss type structure. You can see the very large mirrors at the bottom, the two large mirrors. And it's not obvious, but up here we have a couple of small mirrors. And in order to use this pair of binoculars, you would look through the two eyepieces at the very top here. So clearly it can't be used without either pointing to something lower on the horizon or by getting a stepladder out in order to get your eyes at the relevant height to actually use this pair of binoculars. For some people, two is not enough. And although we tend to think of a binocular might be a handheld instrument that we use for scanning the sky, and when we want to look with more powerful optics we would use a telescope, but for some people, if they want to do astrophotography, they would use rather large telephoto lenses like this. That's a rather expensive one. It costs many thousands of pounds, but it does give you very nice images. But rather than just have one camera and one lens, some people have said, rather than spend money on a large telescope, why don't we buy a large number of small cameras and small telescopes, i.e. telephoto lenses? And that's what they've done. Some people have said this is a more cost-effective way of effectively making a large telescope. You basically build it up out of smaller telescopes. It has the advantage that you don't have to buy them all at once. You can buy a small number and start building them up, especially if money is tight and you can only afford to buy a few at a time, but then funds become available later on. You can start to build them up. So in this case, we have 10 of these lenses with cameras on the back, and they are all mounted onto the same equatorial mount. And so if you wish, you can point all of these 10 telescopes in at the same direction and take 10 images of the same object. Why would you want to do that? Well, because you can collect 10 times as much light as you can from a single telescope, and you're not limited to taking the same sort of image. If you wanted to, you could use filters so that each telescope could take different images. One could take an image with a green filter, one with a red filter, one with a blue filter, or you could have one of the telescopes filtering only the light from the hydrogen atoms in the object, another one filtering the light from only the oxygen atoms in the object, and so you can build up an image by taking lots of images in parallel. And you're not limited to 10. If you're going to do this, why stop at 10? Why not go to 24? And yes, some people have decided this is more cost effective than simply spending large amounts of money on one big telescope. And so a number of different research establishments or universities for whom a few £1,000s for a single telephoto lens is not too much of an outlay, they've decided to go down this particular line. Not all amateurs can afford to take that sort of approach to building telescopes. And yes, size does matter. And for some people, the bigger the better. Maybe it's a man thing, I don't know. But yes, I find it very difficult to believe that you really do want to use this telescope at night. Doing this in daylight, well, you can just about get away with that. But imagine climbing that step ladder in the pitch black. So this particular telescope seems to be placed in the middle of nowhere from the scenery in the background. So yes, you're getting away from any light pollution, but this must be a really dangerous way of working. That stepladder itself doesn't look particularly sturdy, but some people have decided that yes, they want this sort of telescope with the largest possible mirror. And if it's home built, you can make telescopes this size at reasonable cost, meaning perhaps a few £1,000s, but not tens of thousands of pounds. So yeah, some people go down this sort of route. They always want to do one better than their competitors. So what is the largest refractor ever made? The largest telescope that uses a lens? That's often quoted as the great refracting telescope at Yerkes Observatory, which has got a 40-inch lens on the front. But actually, that's not quite the largest refractor ever made. The largest one ever made was made for the 1900 Paris exhibition. The top of this particular graphic here shows the telescope mounted horizontally and permanently installed. The telescope is so large and so heavy it couldn't point at different parts of the sky. So they mounted it as a long tube about 200 feet or 60 meters or so long. It is permanently placed on piers, and light is reflected from the object that you're interested in by this mirror, which is shown in more detail in the bottom panel of this graphic. So there's a mechanism to move this large mirror, which is well over a meter or so in diameter, to reflect light from the object you're interested in into the telescope. And there is the lens of the telescope, 48 inches in diameter, about 1.25 meters. And then the telescope is mounted horizontally and goes off to the right, and at the other end of the telescope, that's where you would have either a photographic plate or an eyepiece. Now, of course, this telescope is of such a size that you wouldn't necessarily stand there to look through the telescope. You can see again from the top graphic how it was occasionally used. If, for instance, you were looking at the moon, the light would be focused by the lens, go down the telescope, the eyepiece would be at this end, and then you would project the image onto a very large screen, a sort of IMAX of its day. So this is an auditorium, nice and dark, so that even a relatively faint object could still be projected onto the screen, and then you would have, I don't know, hundreds or possibly thousands of people in this auditorium all looking at a highly magnified view of the moon or some other celestial object. This was built for the Great Exhibition, and it was designed purely as a spectacle. It was never really used that seriously for a lot of scientific work. And rather tragically, when the exhibition finished after a year or so, they didn't know what to do with the telescope. Nobody wanted to use it. They couldn't keep it installed in this auditorium. They couldn't sell it. Nobody wanted to buy it because nobody could effectively use it properly. And so it was dismantled for scrap, which is a bit of a shame. That's the view. The lens is at the far end of this view. Here is the photographic plate, and that could be replaced with an eyepiece in order to project an image onto a big screen. And that's what the eyepiece holder looked like. I never actually got a good view of, I can't find on the internet anywhere that shows what the eyepiece itself actually looked like, but you can see the scale of this telescope from the person standing on the side there. Quite an amazing construct, an amazing piece of engineering. It's a shame it was scrapped. I believe the lens was kept, but everything else was basically sold for metal scrap afterwards. A lot of amateurs decide not to work in metal if it's easier to work in something else. So somebody has decided they wanted to make a wooden version of the Hubble Space Telescope. I'm not too sure why you would want to make a wooden version of the Hubble Space Telescope. You need a very big garage to put it in, and at the end of the day it doesn't work as a telescope because a space telescope needs to be above the atmosphere, and a telescope of this size would be very heavy and it would be essentially impossible to use. So I assume this is a little bit of a white elephant and was somebody's pet project. Other people do work in wood and they make rather wonderful looking telescopes. Telescopes are easier to make or buy with plastic or cardboard or occasionally metal. These days carbon fibre is quite popular. But of course if you decide to make it out of wood, you end up with something which is truly a work of art as well as a useful scientific instrument. Some people would decide to buy their telescopes but perhaps make the mounting out of wood, which is a sensible thing to do. So here I'm not too sure what this telescope is. It might be plastic, it might be metal, but here the individual has used their woodworking skills to make a fork mounting, a proper fork mounting rather than a knife, fork and spoon mounting in this case. And you can see this equatorial mounting that will allow the telescope to move, but the telescope looks like it could be a commercial instrument. Some people take it to extremes. Russell Porter was an amazing architect and technical designer and amateur telescope maker, and as well as making a number of different relatively large telescopes, he also made this rather beautiful garden ornament which is actually a functioning telescope. You can't actually see it, but there's a mirror down in this base of the telescope, a small diagonal mirror there and a small eyepiece. I don't know quite how well it worked, but it was functional, but it was basically also a garden ornament. Rather beautiful item. And when it comes to craftsmanship, a lot of people put a lot of effort into either making the telescope of their dreams, or you actually make an observatory in your back garden. Okay, I think I've shown you this slide before in another talk. This is the Palomar mounting, where the world's largest telescope when I was a child was the 200-inch or 5-meter diameter mirror telescope called the Hale telescope. I visited it back in 1982 and decided it would be great to have an observatory in my back garden, but I had to downsize my ideas from something that was the size of large enough to accept a 5-meter diameter mirror. I had to downsize my aspirations to something, well, it might look like a B&Q garden shed to you, but actually it's a B&Q garden observatory as far as I'm concerned, with a shower cap on the top that would allow me to unhook it and then see the sky. And that's what it looks like inside. So a standard wooden shed, because that's simply the easiest way of making a housing for an observatory. I wanted to take my telescope, a commercial telescope made by the Mead Corporation, and I was prepared to spend a couple of £100 on a garden shed and convert it into an observatory, which I used for a few years. Some people take their craftsmanship much more seriously, and that's a beautiful bit of work to make yourself a small domed observatory in the back garden. I'm not too sure exactly how big it is. Perhaps you can guess from the flowers in the foreground, or perhaps you can guess from the size of the door. I would imagine it's not a full height door. I think that's the sort of door that opens and you have to duck to get in. So I'm not sure exactly how many meters diameter that is. But you can see that somebody has put their heart and soul into trying to make a observatory dome for their back garden, which is A, functional, but B, also a beautiful work of art. Some people want astronomy on the move rather than a dome in their back garden, and this looks like a wonderful compromise. If you've got a car big enough to tow something that big, it is essentially half caravan trailer and half observatory dome. So I don't know what it looks like inside, but it's a wonderful idea that you have a dome in which you can put a telescope, and when you're done observing, you presumably have a bed and a kitchen, etc. right next door. So yes, if your car is big enough, you can hook up one of these things and take it anywhere. If your house or back garden happens to be plagued by light pollution, well, you just drive somewhere that's nice and dark, get away from the street lights, and then do your observing. If your car is not big enough to pull a dome of that sort of size, maybe you have to think a little bit smaller. Okay, I'm not sure if that's really what's useful, but in principle you could still put a small telescope in that dome. Yes, you couldn't get into the dome with the telescope, but these days lots of telescopes are computer controlled, and so the telescope would sit in the dome and do the observing, and the dome would close if it looks a little inclement and it might rain, and the observer could be either sitting in a car or sitting somewhere else controlling the telescope and perhaps looking at what the camera is seeing if a camera is attached to the telescope. If you want astronomy on the move, again, this is a different way of thinking about astronomy on the move. A go-to telescope. Normally, we think of go-to telescopes as being a telescope in which you command it via a computer to go to a particular object at the sky. In other words, point to a particular object in the sky. But here, somebody seems to have taken go-to literally as making a telescope that can be effectively taken to different places. Again, I'm not too clear as to whether or not this thing is motorized or whether it just latches onto something else and is towed to where you want to use it. But as far as I can see, this is a relatively large telescope which can be taken again to anywhere that you have dark skies to actually make the most of your environment, get away from the city streetlights. This is not necessarily that new an idea because it would appear that somebody's had the idea before. In this case, a mobile telescope, which you can again drive to where you want to actually do your observing. I'm not quite convinced this was ever made as a commercial item. Is this a publicity stunt made by the people who make the car, saying, hey, look at this, there's a telescope on top? Or is it made as a publicity stunt for the people who make telescopes, saying, hey, look, you can put our telescopes on a car and drive it around? That's a very big telescope, and these days you'd have to pay a lot of money for a refracting telescope of that sort of size. And you might ask yourself, well, could you actually use a telescope like that? The telescope's pointing at the horizon. How on earth would you use it to point at something higher in the sky? Oh, don't worry. It's got a little crank handle on the side there, and apparently it does raise itself up so that you can use it for looking at objects higher in the sky. Again, this individual is presumably not looking at anything in the night sky, given that it appears to have been taken in daylight, but you get the basic idea. I can't remember also what year this was. Although I found the photographs on the internet, I couldn't pin down which particular year these images were taken. But it looks like a fantastic idea. And I think somebody must have seen these photos thinking, what a great idea. Rather than try and pack things away in a trailer, why not put a telescope on top of your car? So somebody has taken the idea and modernized it. So here we have a Volvo, a telescope mounted onto a Volvo estate. I think this particular individual lived in Florida. I noticed that the car itself, it's obviously a fairly massive car to take the weight of the telescope, and just to make sure the car doesn't move too much when the telescope is being used, it looks like there's a wooden block propped under the rear bumper, just to give you a little bit of stability so that you can actually use it. And as far as I know, this was indeed used by this individual driving to a dark sky and then using the telescope. Quite how high in the sky you can use this particular one, I don't know, but the idea is there. And it's by no means actually the largest telescope that has ever been made truly mobile. Perhaps it's one of the largest for an amateur, but the professionals, they really know how to move telescopes around. And again, I've showed you this picture before. This is the Stratospheric Observatory for Infrared Astronomy. The telescope itself is sitting in the back of the 747, and the 747 was flown at relatively high altitudes to get above most of the atmosphere, because this was an infrared telescope and the atmosphere absorbs infrared light, so you fly it as high as possible. Infrared astronomy is now being done state of the art with the James Webb Space Telescope that even better get above the atmosphere completely. And so the Stratospheric Observatory for Infrared Astronomy was retired a little while ago. Last year it was taken out of commission. So if anybody is interested, this 747 is now up for grabs. Watch out on eBay, you may get a deal. So for the last few minutes, I've just been taking you through some of the humour that I've trawled and found on the internet over the years. A few cartoons here and there, a few interesting looking telescopes here or there. If you want to learn more or go and find more cartoons or humour in the same vein, then you can always go and visit these various web pages. Again, I'll make the handout available to you so you don't have to make a note of any of these addresses. I'll pass them on to the organisers in due course. I hope you found at least some of that reasonably amusing. Thank you.